Hello everyone, welcome to the debugger guy. So this video is going to be about the two methods that system class provides, the current time millis and the nano time. So recently I raised a merge request at the work and the code looked something similar to this. So I was just measuring the time that a particular task takes for the computation that involves the external service interactions, DB calls, and much more. So I was just logging like this task takes this much time, and the code is like pretty much looking similar. That okay, start time, end time, and the total elapsed time in millis, and logging it also. So my tech lead reviewed this code and gave a review comment that we are measuring the elapsed time, use NanoTime instead of current time millis. So the very first thought I came to my mind that is it because the current time millis gives us milliseconds precision, whereas the nano time gives us nanotime precisions? So I just started researching what what's wrong with the system the current time millis and why we should be using or the nanotime. Okay, so just like everyone, the first thought would come like same like nanotime maybe provides the more precision. That's why my tech is asking. But I was again thinking like ultimately we are going to log in the millisecond only, so why to use? Okay, so the main issue or the thing is not the issue but the feature or the how the system current millis work. It represents the current wall clock time. So if I'm calling the current time millis at this current time, it returns me the same, the milliseconds in the current wall clock that is happening. So if my current wall clock changes in between due to any reason, let's say the clock synchronization happens or someone changes the clock or maybe daylight savings or something similar happens, the start time measure something, let's say 2206, and the synchronization happens and it the clock gets reset to maybe by 1 minute or something, and the next current time millis calls, since it is measuring the actual clock time, it would give us 2205 and my current millis would be negative. That it would that is fundamentally wrong. That time cannot be negative. So the issue is it is not monotonic. So monotonic clock is something that always moves ahead in time, similar to there is a concept in distributed system like monotonic rates where if our data is replicated to multiple replicas and if we're reading it, so we should always be the rate should always be monotonic. That means every read should go ahead in time. It should not be going back. So if one replica is lagging, another uh, and request goes to this means that is like a distributed system should maintain. That is beyond this video, but yeah, this is something similar concept. Okay, so coming back to the MR and the question. So I thought of tried replicating the same system just by theory that looks fine, but more fun comes when you actually do something and get to know okay that really happens. So let me do one thing, let me run it just to have some fun. I started processing it. I'm not going to change anything under normal conditions. uh, let's see how it goes. I have put a thread 20 seconds of sleep time so that I can maybe adjust the system clock comfortably and then we can see the results. So under normal conditions, it measures the time perfectly. Okay, fine. Let me clear the console and run it again. And meanwhile, I'll just do this something. I'll just set the date and time manually. It is, let me reduce it by 1 minute. So I have moved the time to 1 minute in past and see what happens. The start has, okay, so that is great. We see 45 seconds in past, right? So that is the issue with the current time millis. If your current wall clock changes due to any reason, we would see uh, incorrect value. It can be negative or highly positive. That is not expected. So, okay, so let's change it to nanotime and see how it behaves. Since nanotime is monotonic in nature, if even if we see the system logs, returns the current value of JVM's high resolution time source in nanoseconds. Okay, perfectly fine. This method can only be used to measure the elapsed time. So for measuring the elapsed time, that is the preferred method to use. Let's let me comment it out because it is providing us in the nanoseconds. The time unit is nanoseconds, maybe the precision may not be nanoseconds, that depends on the hardware, but that is a different story. Let's run it again, and okay, it started. Let me do the same thing again. I will just go from 09 to 07. Okay, change the clock again and see if it has any effect or not. Okay, few more seconds to wait. Cool. As expected, since it is monotonic, it always moves ahead in time. So it is unaffected by your wall clock. So we would always see the correct value. So the thing is like if you go to the JVM internals, like how this monotonic clock, so actually differs from the system clock. It comes down to the um, like the operating system processes or the counters they maintain. So every operating system has some timer for this monotonic clock purpose, like nanotime. So even like Mac, every operating system does the same. So it is not because of the nanotime precision, we should be using the nanotime to measure the elapsed time, but it is indeed the monotonic nature that makes it suitable to measure the elapsed time. So rule of thumb, if we want to get the current time, you should use the current time millis, but if you want to measure the elapsed time between of the operation, we should always use nanotime. So thank you. If you found it helpful, feel free to share it with your friends. Thanks.